Hi, today we're going to be looking at lesson 4.2, solving linear inequalities. And the goal for today's lesson is to solve linear inequalities. And when we accomplish this goal, that will allow us to solve polynomial inequalities in lesson 4.3. So if we're given an inequality, the result would be stating all the possible values that satisfy a given condition. Whereas for solving a linear equation, there will only be one solution. So if we're looking at the equation 3x minus 5 equals 13, there is only one solution, which is a unique solution, which is x equals 6. Whereas if we look at the inequality 3x minus 5 is less than 13, x equals 5 satisfies that inequality because if 5 were substituted into the left side of this inequality, the result would give you less than 13. But also, not just x equals 5, but x equals 2 would also satisfy that inequality. So at x equals negative 15, 5.9, etc. So any value, basically, that's less than 6 would also satisfy this inequality. So we're looking now not just for one value, we're looking at a value to kind of start from, but we're looking at a range of values that would satisfy the inequality. So as it says here, all real numbers less than 6 generate a number that's smaller than 13 or less than 13. So all values that are less than 6 would satisfy this inequality. So we could look at it on the number line, place our 0, place our 6, and if it's less than, then we would draw an arrow to the left of 6, and because it's not equal to, that means that 6 is not included in the solution set. Therefore, we have an open circle indicating that 6 is not included in the solution set. So we can write this in set notation or in interval notation. So if we were to write the solution to 3x minus 5 is less than 13, in set notation we would write it as x is an element of all real numbers such that x is less than 6. Or in interval notation we could say x is an element of the range between negative infinity and 6, with round brackets indicating that neither of these are actually included in the solution set. Okay, so here's a couple examples where we can solve these inequalities algebraically, and then we can test them graphically. Okay, now I had posted a couple links for free online graphing calculators a few weeks ago. Check the class portal and take a look at the new link. It's a link of a website called Desmos, D-E-S-M-O-S, and just launched the calculator. It's an online application, and it's pretty terrific for seeing inequalities or even just graphing lines and finding intersection points where you can click on the points of interest button and it'll show you all the points of interest that would occur on the lines. Okay, so you can check your algebraic solutions by going to desmos.com. Okay, so for example A, we've got 3x minus 1 is less than or equal to 11. So let's go about solving this first of all. I'll do this one graphically first, I suppose. And so basically when we have something like that, graph the left hand side as 3x minus 1, so as its own line, y equals 3x minus 1, then graph the right side as its own line, y equals 11, and see where they intersect. Okay, and then you can analyze them from there. So I'm just going to sketch a small curve here, or a small graph. Okay, there's the coordinate axis. I'm going to say 11 is about here. Okay, so that's y equals 11. And then I'm going to graph 3x minus 1. So let's say that this is minus 1 roughly, and 3x will be fairly steep. So there's 3x minus 1. Okay, so we have a point of intersection here. And now on an actual grid you'd be able to tell exactly what that point is, unlike my very crude illustration of the Cartesian plane there. And through the magic of prior knowledge, we see that this is 4. So now if we're to look at this, analyze this, we're saying, when is 3x minus 1 less than or equal to 11? Well, here's the line 3x minus 1, and we want to see for what x values would this line 3x minus 1 be less than or equal to this line of y equals 11. So we see the intersection point is x equals 4, and because it's less than or equal to, that means that x equals 4 is included in the solution set. And so 3x minus 1 is less than or equal to 11 for all x values to the left of x equals 4. To the right, 3x minus 1 is above the line y equals 11, which is greater than y equals 11, but to the left of this point, the line y equals 3x minus 1 is less than or underneath this line y equals 11. So the solution set would be x is less than or equal to 4. Okay, so basically, to write it formally, we'd say the solution is x is an element of all real numbers such that x is less than or equal to 4. Okay, or of course we could also write x is an element of negative infinity to 4. And this time we have a square bracket because x equals 4 is indeed included in the solution set. Okay, so that's the graphical solution. I don't have a whole lot of room for the algebraic. I'll put it over here, I guess, here. So if we have 3x minus 1 less than or equal to 11, then we just treat this like most equations, and we'll just do the same thing to both sides to maintain the balance of that inequality. So I'll add 1 to both sides here. So we get 3x less than or equal to 12, and then I'll divide both sides by 3, so x is less than or equal to 4. Okay, which is what we found here. Okay, so we'll take a look at this other side now. This other example. And I've graphed this before, so I know how to set up the Cartesian plane to show us the results that we're looking for. And so now we're looking for negative 2 quantity 1 minus 2x less than 5x plus 8. So where in the Cartesian plane, in terms of x values, for which values of x would this negative 2 quantity 1 minus 2x be less than this expression 5x plus 8? So I will draw 5x plus 8 here, and of course again a very crude drawing for this. Okay, so the scale's off a little bit obviously. So that would indicate 8. So this is the line here, y equals 5x plus 8. Probably the steepness of that is not accurate to the steepness of the slope of the actual line, but please bear with me. And then if I were to expand this in, I'd get negative 2 plus 4x. So plus 4x minus 2. So again, it would be pretty steep. So it would be something like that. And I realize that this value of negative 2 is a lot further away from the x-axis than is this x value of positive 8. But we're getting the idea. I would hope that you could graph this on grid paper and draw a more accurate graph here. So this is 4x minus 2, and this graph is y equals 5x plus 8.